All right, so 8.1, I need a quiet, please. This will go quickly. All right, when you multiply two numbers together to form a product, each of those numbers is called a factor. So that's the first blank there. You're going to write in the word factor. And then what we're going to do in here is we're going to do a prime factorization. So then over on the side over here, you don't have to write this if you don't want to. What's a prime number? If it's not prime, it's called composite. Anybody got an example of a prime number for me?
19.
Yeah, 19 would be a prime number.
Oh, they're odd numbers, right?
No, they're not necessarily odd. 2 is prime. Like 19 is prime because you can only write it as 19 times 1, right? That's the only way you can write it. Like, for example, 24. That is not prime because 24, you could write it as, you could write it as 2 times 12. You could write it as 4 times 6. There's a bunch of different ways you could write it. What's another example of a prime number? 4 is not prime. 4 is composite. Because 4, you can write it as 2 times 2. What's that?
17.
Don't bring that up. 17, yep, 17 would be one. 3, yep. 3 is prime. 13 is prime, yep.
6 million.
That is not prime. All right, so again, prime numbers, not 8. 8 can be written as 4 times 2. Okay? So they're prime if you can only write them like 13, you can only write it as 13 times 1. All right, 17 is prime because you can only write it as 17 times 1. Yeah.
What about 6,987?
I don't know. I don't care. All right, so there's some examples of some prime and composite numbers. So then what they're going to want you to do is factor a number. So they have an example written out here. So they're factoring the number 56. So they wrote it as, now I prefer to write these like this. I would do, it's 2 times 28. And then the 28, you can break that down into 2 times 14. And then the 14, you can break that down into 2 times 7. So when I make a factor tree, I kind of do it like that. But then what I would do with my factor tree is I would bring this 2 down right here. So like this right here. And then I would bring this 2 down right here. So something like that. So then I could see that the final answer would be 2 times 2 times 2 times 7. That would be 8 times 7, right? And that's 56. But again, they don't do that in the book. That's not how they do it. They kind of look at it like, if I erase all this, they kind of look at it right here. Like, they look at it as 2 times 2 times 2 times 7, like that. So that would be 2 to the 3rd power times 7. That's a prime factorization because the 2 is prime and the 7 is also prime. So you're breaking it down into the product of just prime factors. So let's do another one. I'll kind of do it the way I do it. So maybe on the side over here, I don't think they said try 98. Let's do like 48. So we're going to do a prime factorization of 48. So 48, what could you write? What times what equals 48?
12 and 4.
You could do 12 and 4. Anything else you could do? Well, 48 and 1, we know that one. What's that? 2 and 24, yep, you could do that. You could do 16 times 3, you could do it a bunch of different ways. But the idea is you want to break it down into prime factors. So let's do, so again, how I kind of do this is I do it like, you could do 6 and 8. I'm going to do 2 times 24. And then what can I break the 24 into?
12 and 2.
Yeah, 12 and 2, 6 times 4. Either way, it'll work out in the long run. So I'm going to break it down into 2 times 12. Like that. And then I'm going to bring this 2 down. So right now I have 2 times 2 times 12. All right, and then what can I break the 12 into? 6 and 2, yeah. So then I could make this 6 times 2. And then I'll bring this 2 down. And I'll bring this 2 down. So this is more how I do it than what the book does. It's a factor tree. I kind of make it, it looks like a tree when I'm done. And then what could I break? Well, actually, let me write the, it doesn't matter, but let me write the 6 times 2. I'm going to write it as 2 times 6. So hold on. I'll do it as 2 times 6. All right, now what can you break the 6 into? What's that? I still can't hear you guys. I got the fan running right behind me, so I can't hear.
3 times 2.
3 times 2, good. Or 2 times 3, either way. So I'm going to break this down into 2 times 3. And then I'm going to bring this 2 down, and I'll bring that 2 down, and I'll bring that 2 down. So that's kind of how I do it. So then you can see the final prime factorization is right here. It says bottom line, this part. You got 2 times 2 times 2 times 2, which would be 16. 16 times 3, which is 48. Yep. But notice that all those numbers that I just wrote down there in that final line, these are all prime, right? 2 is prime, and the 3 is prime. That's why it's a prime factorization. It's a product of, you wrote the 48 as a product of prime numbers. So the factors are prime. But anyways, yeah, so then you could end up writing the final answer. You could write 2 to the 4th power times 3. All right, so that's how you make a factor tree. And again, you could do it like the book does it if you want. That's the way I always did it. All right. Here, it looks like a little tree. It's a happy tree.
That's good time.
Yes. I should have done it in green, though. I should have done it in green. And I could put the numbers and the dots in like red and, I don't know, red and yellow. That would have been good. I wish I would have thought of that. All right. But I'm not going back to do it. All right. Factors that are shared. Do we got all this stuff? Yeah. So factors that are shared by 2 or more numbers are called common factors. So right here you want to write in common. So for example, on the ones we had here, 56, that definitely had a factor of 2, right? And then also you can see our 48, that also had a factor of 2. So 2 would be a common factor for 48, and 2, or I should say, 2 would be a common factor for 48 and 56. Because 2 divides evenly into both of those numbers. So really what a factor is, it's a number that divides evenly into that number. All right, and then all even numbers have 2 as a common factor. So you're going to fill in a 2 right here. If 2 does not divide evenly into the number, then I would try 3. Okay, and kind of go from there. Now we're going to talk about the greatest common factor. This thing right here. So the greatest common factor, they call it the GCF. I'm not going to write this out, but this is what it is. Listen, the greatest common factor is the largest number that divides evenly into both of the numbers. Okay? So when you look at number 2 here, when you look at the 15 and the 25, you want the largest number that divides evenly into both of those. What did you say, Kyle? Yeah, it's 5. So this one, the GCF, the greatest common factor, is 5. Again, it's the largest number that divides evenly into both 15 and 25. That's your greatest common factor. What about number 3? What's that?
10.
Bigger.
30.
20. 20. You want the largest number. I mean, 10 is a common factor of 160. All right. 10 is a common factor, but we want the greatest common factor. So we want the largest number that divides evenly into 100 and also into 60. So that one is going to be 20. So the GCF on that one is 20. And then number 4?
13.
Yeah, actually 26. Yeah, actually 26 divides evenly into both of them, right? 26 divides into itself once, and 26 goes into 52 twice. So this one, the greatest common factor is 26. So even though I didn't write it down, are you guys okay with that? It's the largest number that divides evenly into both of those numbers. All right. Then we're just going to do the same thing on 5, 6, and 7, but we're going to also have variables with powers involved now. So the first thing we're going to do on number 5 is what's the largest number that goes into the 18 and the 27? That's a 9. That's good. So the GCF, greatest common factor, it's going to be 9. And then is there a G in both of those monomials?
Mm-hmm.
Yes. And then you want to say, what's the lowest power that it appears to?
2.
A 2. So you put it, so it's going to be G to the second power. So that's going to be your greatest common factor. Same thing on number 6. What's the largest number that divides evenly into the 15 and the 9?
3.
Yep, that's a 3. Is there an X in both of those terms?
Yes.
Yes. And then what's the lowest power it appears to? Squared. Now some people say, why is it X squared? Well, you got to remember this one, this first term here, this would have an X times an X times an X, right? Because it's got an X cubed. And then this one over here is an X squared, so that has an X times an X. Well, what do they have in common? They both have an X times an X. Do you see that? They both have an X times an X, so that's why X squared, okay?
So you take the lowest one?
Yeah, so it's going to be the lowest power that the variable appears to. And then number 7. Oh, I didn't write that was the GCF. I guess I could do that. And then number 7. What's the largest number that divides evenly into 8 and 7? What's that? Yeah, it's only 1, right? And is it the same variable in both terms? No, so those are not in common. So that's it. The greatest common factor on number 7 is just 1. All right, and then we just got this little word problem here to do, and we're done. Whoop. Well, I just messed something up. I don't know what I just did. I just lost everything I wrote.
It's still on the screen.
Yeah, it's still on your screen, but I can't get it. I can't get back on my screen. Let's see if I go out and if I go back in, maybe I can do it. Oh, let's see. That's not going to do it. Yeah, I don't know what I'm in now. Hold on. Give me a second. Oh, let's see. Let's try this. Let's try this. There we go. All right, I got it back. All right, so we got to do this word problem, so hang on one second. All right, this says they have 18 chocolate milks and they got 24 regular milks. The cook wants to arrange them so that there's the same number of cartons in each row, but each row is not mixed, okay? So there's not chocolate milk and regular milk cartons in the same row. And they want to know how many rows will there be when they arrange them so they put the greatest number of cartons in each row. So each row has to have the same number of cartons in it. So all that's going to be is that's just going to be the greatest common factor for 18 and 24. Yeah. So the GCF for 18 and 24, that is going to be 6. That means there's going to be 6 cartons in each row. So let me draw you a little picture of this here. So this would look like this. So you'd have, for the chocolate milk, you would have, I'll put C for chocolate. So you're going to have C, 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 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So there's 18 chocolate milk cartons. There's 6 in each row. You guys see that? That's 6. All right, and then for regular milk, well, I'll just put R. So for the regular milk, you're going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You see that you got 24 of those now? So the number of cartons in each row was the greatest common factor of 18 and 24. Now hopefully down there in the blue you can see that, I'll zoom in a little bit for you guys, there you go. Hopefully you can see there's 24 regulars there, 24 R's. And then, so how many rows is there altogether then? So how many rows are here?
7.
Yeah, 7. So that's the answer to the question, how many rows would there be? So there's 7 rows. So there's 7 rows of 6 cartons. All right, I think that's it.
Yep.
All right, so let me stop this recording.